My name is Barry Smith. I'm the Program Director for Information Technology here at Virginia College Online, and I'm here to help you out in better understanding topics that you're going over in class or things that you will be going over in class. Just kind of help hammer things home a little bit, because I realize that reading all the time can be a bit strenuous and can not fully give you everything you need to know. So hopefully these videos will help you out. The first thing we're going to talk about, or the first topic I want to cover, is the topic of binary numbers and the importance of binary numbers in the world of computers. You may not know it, but the world of binary and binary numbers is the only thing ultimately that your computer understands. And when I say computer, I mean everything from your desktop computer to your laptop, tablet, your cell phone, PlayStation, Xbox, any electronic device really only understands two things. And those two things are on and off. And that's where we come into binary numbers. In the world of binary, there is only two numbers total in the entire numbering system, 0 and 1. 0 represents off, 1 represents on, and that's it. There's nothing else. There is no in between. There's no various levels of on or off. It's either on or off. Now, the numbering system that we've been taught our entire lives, ever since we were kids, is a numbering system called the decimal numbering system, and you see that right here. The decimal numbering system is what we call a base 10 numbering system, and it consists of the numbers 0 through 9. If you think about it, every number, any number you can think of, will actually only have numbers 0 through 9 in it. You can go into tens and thousands and millions and billions of places, but it still is numbers 0 through 9. Well, in the world of binary, it's much simpler than that. It's two numbers, 0 and 1, and it will always be just 0 and 1. In the world of binary, there's no such thing as a tens place or a hundreds or a thousands. It's either 0 or 1. So it's very simple in that regard. One of the things that you have to understand how to do, and one of the things that you must do if you want to be a good network administrator or network technician, is you have to understand the relationship between decimal numbers and binary numbers. You also need to understand how to convert numbers between decimal and binary, and vice versa, back and forth, because when you get into things like IP addressing, subnetting, and some more advanced routing things in some future classes, it's really going to be important for you to understand how to do this, because that's how they work. That's how the devices themselves work. It is a very easy thing to do. It's very simple. In fact, here in about 5 or 10 minutes, I'm going to have you converting binary numbers from binary to decimal and back again, because it is a very simple and easy process to do, but a very important process, I might add. If you look here on my board, here at the bottom of the board, you see that I have numbers written across here into columns. If you will look, you may have already noticed a pattern of these numbers. If you look over here to the far right, we have the number 1, and then if you keep looking at the numbers as we move left, we basically take the number and then we double that number and we put it into the next column. So 1 doubles into 2, 2 doubles to 4, 4 to 8, 8 to 16, and so on all the way over here to 128. This is what we call a binary calculator. This is a homemade binary calculator. You don't need a computer, you don't need the internet, you don't need anything, cell phone or anything, to convert binary and decimal numbers. All you need is this little chart right here. This does everything for you. You may have noticed, or you may have seen in your computer careers, some odd numbers that you kind of wonder, where did they come from? Why did they come up with that? Like, for instance, you may have seen something like 32 megabytes of RAM, or you might have a 16 gig thumb drive or a 32 gig thumb drive, and think, where did they come up with 16 or 32 or 512 or 1024? And the reasoning for that is because the number comes from converting the decimal number, 32, into binary. And as you can see right here, one of our places in our calculator, binary calculator here, is 32. Same with 64 and 128. So these numbers that you see that may seem a little off are actually very much accurate when it comes to converting decimal numbers into binary. And that's where it all comes from. So let me show you how to do this. First and foremost, you have to understand, again, that binary numbers is either 0 or 1. So whenever you see a binary number, you're either going to say 0 or 1. For instance, we'll use the number 0, 1, 1, 0, 0, 1, 1, 0. This is 8 binary digits, and you would say it exactly how it reads. Now, most people, when they see a number like this, the first thing they want to do is they want to go in, because they remember this from school, from elementary school, they want to put some commas in here, and they would say, okay, that's 1,100,110. Well, it would be if it was a decimal number, but it's a binary number, so we say it exactly the way it reads. It is 0, 1, 1, 0, 0, 1, 1, 0. It is that simple. Now, we need to figure out, or we need to determine, what is the equal of this number in decimal. This is a binary number. We need to get its decimal equivalent. So what we need to do, and what we will do, is we will use our trusty binary calculator. It's that simple. What we'll do is we'll take each one of these numbers, and we will plot each one of these numbers into their own column. So we will take this number here. One number goes into each column. 0, 1, 1, 0, 0, 1, 1, 0. Now, all we need to do at this point is we need to look, and we need to remember that 0 means off and 1 means on. So what you're doing is, what you want to do is you want to look at all of the columns that have a 1 in the column, and when you see a 1 in the column, you need to think that that column is turned on. Therefore, the number above the 1, the binary 1 that you see, the number above this is an active number. So we take all of the columns that have a 1 in it, we look at the number above the 1, and then we simply add these numbers together, and that will give us our decimal equivalent of our binary number. So in this case, as you see here, we have a 1 in the 64 column, we have a 1 in the 32 column, a 1 in the 4 column, and a 1 in the 2 column. So we're going to add those 4 numbers together. 64 plus 32 would be 96, plus 4 would be 100, plus 2 would be 102. So the decimal equivalent is 102. This number and this number is the exact same thing. One is in the binary numbering system, one is in the decimal numbering system. It's that simple. That's all you have to do to convert a binary number. Now, if you want to go the opposite route, give me just a second here. So let's say that you have a decimal number and you want to find its binary equivalent. We just converted a binary to a decimal, but what about converting a decimal to a binary? So let's just come up with a number. Let's just make a number up. We'll say it is 217. So what you want to do here is kind of reverse what we just talked about. We want to find out, in essence, what plus what plus what is going to equal 217. It's that simple. So we need to start over here with 128. And what I do, and to me the easiest thing to do, is kind of start dividing the numbers into the number, and I'll show you what I mean here. So does 128 go into 217? Yes or no? Not how many times, not any remainders, but just yes or no, can 128 go into 217? If the answer is yes, then we must put a 1 in that column. Alright, so 128 plus 64. Can these two numbers added together go into 217? So 128 plus 64 actually is 192. Does 192 go into 217? Yes, obviously it does. So there would be another 1 here. So 128 plus 64 plus 32. Well, 128 plus 64 is 192, plus 32 is 224. Does 224 go into 217? Obviously not, it's too big. So in this one we will have a 0. So now we're back to 192 plus 16 is 208. Can 208 go into 217? Obviously it can. So there'd be a 1 there. Now, 208 plus 8. 208 plus 8 is 216. Will that go into 217? Yes, it will. So there'd be a 1 there. 216 plus 4 is 220. Obviously that's too big. 0 there. 216 plus 2 is 218. Obviously too big there. So another 0. 216 plus 1 is 217. And there's your binary equivalent. So again, it's just a matter of what plus what plus what will equal this number here. So 217 in decimal is equal to 110110001 in binary. And you can go back and forth with this, and in fact I highly encourage you to do so. Write down the little binary calculator on a piece of paper. Just take a piece of paper, write this down, and then just come up with a binary number and then convert it. And do this a few times. Do the same thing with converting a decimal number to binary. Go back and forth with these things, and I'm telling you, it will help you down the road very, very much so. This is it for the binary lesson. Thank you very much. Hope you have a good day.